Hi everyone, thank you for joining us today. It's a pleasure seeing you all at the Hero House Artificial Intelligence Incubator Demo Day. I am Lilith from SmartGateVC team managing the Hero House AI Incubator. Today, representatives of 12 selected company supervisor research groups will present their AI research achievements. But first, please welcome SmartGateVC partner and Program's Chief Scientist Vazgen Hakobjanyan to deliver opening remarks.
First of all, I want to thank EFSE for giving us opportunity to run this program. I believe this program is exceptional, and today you will see why. We already got a lot of different achievements, and this is a unique program that bridges AI students and supervisors with the real world companies and problems, and its impact is really immersive. So today we'll see applications of AI starting from fitness applications and ending by robotics and news sites. So it's going to be very exciting, and I'm very proud that almost all our teams get really promising results. And once again, big thanks for EFSE for supporting this initiative, and especially in these times, these challenging times, it's very important to have these programs, and I believe this type of programs are one of the most impactful ones that can be done in these situations. So again, thanks a lot, and have a great demo day. And good luck to everyone.
Thank you, Vazgen. European Fund for Southeast Europe Entrepreneurship Academy and SmartGateVC joined forces for the second batch of the Hero House AI Incubator program. So please welcome Markus Eschendorf, Chairperson of the EFSE Development Facility, for a welcome address.
So hello, everybody. Good evening. Hello, everyone, and hello from Frankfurt. My name is Markus Eschendorf. I'm the chairperson of the EFSE Development Facility. And it has been an honor working together with impactful organizations such as SmartGate and Catalyst Foundation to support the next generation of Armenia's high potential tech leaders. When I was visiting Armenia 2 years ago, when we were still able to travel, I was impressed by the vibrant startup and tech scene in your country. Therefore, it is my great pleasure to join you for today's online event. And the bright side for the prevalence of virtual events these days is the easy way we can all come together across borders for connection and discovery. But believe me, I would have preferred to travel to Armenia rather than sitting here in my room under the roof and talking to you. The EFSE Development Facility actually has a long history of collaborating with SmartGate and Catalyst Foundation. We are already entering into the third year of joining efforts to foster a conducive entrepreneurship ecosystem in Armenia and boost impactful tech investments. Why is this important? From my understanding, Armenia is on a good track toward high international competitiveness in tech niches, and we have seen an evolving number of tech ventures with potential to scale up globally. However, there are also challenges, such as brain drain, that can stand in the way of making Armenia a hub of tech innovation. That is why we aim to help build up paths that enable local talent to focus right here on developing high-impact, scalable businesses. Collaboration is key. The Hero House Incubator is a great example of how we can leverage existing knowledge by tightening collaboration between universities and businesses, and how investing in our research and development can increase knowledge generation, competitiveness, and youth retention in your country. In addition, the program also aims to facilitate access to capital via cooperation between accelerators, venture capitalists, and universities. And this ultimately contributes to talent retention and, in the end, the creation of income and employment opportunities, not to mention all the excellent tech advancement that we will be unleashed upon the market. Indeed, It is the mission of the EFSE development facility to develop vibrant ecosystems that enable young entrepreneurs to turn good innovative ideas into viable businesses. We are pleased at the opportunity to benefit in this mission from a strategic partnership with investors like SmartGateVC. I would like to especially thank the researchers, mentors, and other dedicated participants for their key role in bringing projects like this to life. Your motivation made the achievements possible, which we will see tonight. And finally, a big congratulations to the visionary entrepreneurs who will share with us the results of their hard work today. It is a privilege to gain a glimpse into tomorrow's tech with you. Now let's get started. Thank you and all the best for tonight's event. Thank you very much.
Thank you. Now, before we move on to the demo presentations, I'd like to tell you about the Hero House AI Incubator. The 26-week program targets startups with a solid volume of data and matched them with student research groups supervised by leading professionals from the industry and academia. The initiative nurtures the growth of deep technology companies in the region by supporting the emerging wave of companies. Overall, 12 companies, 24 student researchers, 7 AI research supervisors, and 2 leading chief scientists, Vazgen Hakobjanian that you already met, and Heran Dakhtian, founder at Metric and lecturer at the American University of Armenia, are involved in the program. It is worth mentioning that several companies and supervisors joined the program from the US and Europe. The research groups worked on creating AI solutions to increase the scalability of the participant startups and introduce new business models for them. Simultaneously, the students involved in the research group gained practical experience while working under the supervision of experienced AI professionals. In several cases, the students used this research for capstone projects. Additionally, the companies received access to talent in universities, and most companies are planning on continuing this collaboration. The program brought the companies one step closer to participating in acceleration and incubation programs, which several companies have recently applied to and been selected, which in turn makes them more ready for investments from funding vehicles like SmartGateVC. The research projects varied from computer vision, neural networks, speech processing, and project planning to natural language processing and other areas for companies in the entertainment, medical, fitness, gaming, and other industries. These are the companies you'll meet today. If you have any questions to the research teams, write them in the call chat and we'll answer them at the end of the presentation. Thank you for your attention. We'll be now moving to the presentations. Please welcome Nana from Foodstruct.
Okay. Good evening to all healthy lifestyle enthusiasts and to everybody. Today, me in the scope of AI Incubator and Mariam Sargsyan with our supervisor Grisha Tadevosyan and Foodstruct's representative and co-founder David Alanakyan will present our project and results. Before going on, we want to shortly introduce Foodstruct. Foodstruct is a diet analyzer, and not only, it also allows to compare 2 foods or to search for foods that are rich in certain vitamins. We hope that after this presentation, you will explore all the tools by yourself, but it basically gives a detailed feedback on our diets. Users have the analysis is done based on several factors. The users have to choose their age, gender, physical activity level. Don't worry, you don't have to do it now. The users also have to choose and type in every food and drink that they have consumed during the day. And the magic happens. Foodstruct shows which vitamins are lacking from our diet, and it also shows several recommendations on how we can refill them. This is fun, right? And we can also see from the numbers that the tools of Foodstruct are practical and useful because the organic traffic of Foodstruct has been increasing and Foodstruct has worldwide users. However, could you hear in between my words that the users have to type in manually every food and drink that they've consumed during the day? Well, that was the initial reason Foodstruct decided to join the AI Incubator. So our mission was to create a food classification program, or in less boring terms, we wanted people to take a picture of their food and our program to be able to tell which food is in the picture. So we have created a model based on a dataset that included 101 different foods. Currently, our model achieves top 1 accuracy of approximately 97% and top 5 accuracy of 99%. Why do we have a slightly higher percentage and accuracy for top 5? That is because of the way top 5 accuracy gives the results. It basically gives a list of 5 foods that each with a corresponding percentage that our model thinks is in the picture. Not to bore you with more numbers, percentages, and terms, we have prepared a short demo of how our newly born model works. So let's watch that. So we have created our model using transfer learning, and to explain it in a more fun way, there are basically many other enthusiasts like us who want to classify other images. So they built models and their existing knowledge already have so they have existing knowledge on classifying and recognizing some objects in their images. So we have used that existing knowledge and added, improved, and changed a few things to get our model. The changes that we have done were based on extensive research. We have very promising results, and that is why we have several milestones in our minds regarding this project. Even better results would require even larger data sets. Currently, our model can recognize 101 different foods, several of which you saw just in the video. However, there are much larger data sets that contain foods and different dishes from different cultures that are expected to result in increased performance. After this, we also want to concentrate on creating an object detection program, which is basically showing and understanding that there is a picture of food and showing it with a simple rectangle like this. After completing this stage, we also want to work on getting near real-time object detection. This was all. Thank you for listening. We hope we didn't make you hungry after our video, but we hope that you will always stay hungry for knowledge. If you have any questions or comments, do not hesitate to contact us or just drop them in the chat. Thank you for being present.
Thank you for the presentation, Nana. Now let's meet Mushak from the Workya.
Hello, everyone. I'm Mushak, the CEO and founder of the Workya. Do you know that 66% of software projects usually run over budget and 33% of them are overtime? The problem is that estimations are always rough and subjective, and historical data is never used to improve them and create accurate estimations. At the Work, we have decided to solve this problem with artificial intelligence, and we came to AI incubation program with a simple technical problem: to predict task estimation based on task textual data, which is title, description, and other information available in the task. Before moving forward, I would like to introduce our amazing team that has been working on this problem during last 6 months. So please welcome Asparam Grigoryan and Knarik Merian, who joined us as a researcher. Mel Sakopian was supervising, and me joined as a business representative. Now I want to pass the presentation to Knarik. Knarik?
Thanks, Mushak-Jan. Hello, everyone. So here is the plan how we have approached our problem. For data, we looked for publicly available open source projects and managed to collect more than 2 million data. Motivated by recent advances in applying deep learning methods in natural language understanding tasks, we have chosen a neural network as our model architecture. And through iterative process, we have chosen the training parameters that give the highest score. And now we are at the stage of improving our algorithm to get better results. Asparam?
Thank you. Our model was multi-layered. Non-technically speaking, we start with textual descriptions, turn those words into vectors, into numeric values. Later on the next layer, we learn order dependency in the sequence of those vectors. We optimize it with more depth and then estimate a number at the end. Here you can see the results we have achieved so far. We tried the model both with regression algorithm and the classification algorithm at the end. For the regression model, our error was about 1.9 hours. for the classification model, you can see the matrix of test predictions on the right. I don't see the slides. Is it only me or? Yeah, you can see the matrix of test predictions on the right. We chose 50 random data points, and you can see, for example, how 8 different development tasks that were actually completed in 16 hours were predicted to be performed in 16 hours.
Thanks. And in this demo, you can see how our neural network works. So we take few tasks that has title and description, and we pass to our neural network. And so the neural network will predict the estimated time spent on each task. And as you can see, for this particular 3 tasks, it estimated exactly the actual data. For example, 1 hour for the first, 4 hours for the last one, and so on. So this is how it works. What's the next? So we are planning to collect more data. For example, more information about task categories, seniority level of the developer, etc. We are going also to categorize tasks in technical language to be topic modeling. We are also going to try some advanced techniques in our neural network architecture, which is transformers, if it makes sense for you. And obviously, the end goal is to apply the same algorithm on the commercial data set, which we are currently collecting. And in case of successful results, to deploy this model to the production. Thanks for watching. If you still have some questions, please drop them in a Google Meet chat or send me an email. Thank you.
Thank you to our AI team. Now let's welcome Laura from Formspotter.
Alrighty. Hello, I'm Lara Vartanyan, the company representative for Formspotter. I'm a recent grad from Columbia Business School in engineering, and I'm also a certified personal trainer. During my experience, I've always come across people with bad form at the gym. You've probably also experienced yourself or seen people lift more weight than they should, which compromises form and leads to injuries down the line. The problem is that people can't afford personal trainers and hesitate with their form during exercise because they lack the kinesthetic sense. Others want to get fit, but are scared about taking the initiative because they don't know how to. So hence, we see a huge opportunity to bridge that gap of a personal trainer's feedback at an affordable price and apply this to college sports training programs as well. Our mission is to democratize fitness and make coaching affordable and accessible to everybody. We provide an affordable and convenient solution to receiving feedback on your exercise form on desktop or mobile using pose estimation technology and AI. Some of the challenges we faced were getting the machine to recognize the human body key points, and then transferring the domain expertise to the machine, and providing a form assessment on the exercise, whether it's proper or improper, and providing the appropriate feedback. During our incubation time, we explored and implemented real-time pose tracking on desktop and mobile, defined mathematical rules, and created assessments for the plank, squats, and push-up. You can see the following key points the machine tracks on the human body. And now Grisha demos the plank for us on Android. So we focus on the key points that are relevant for the plank. Our algorithm detects his optimal form on our left side. So you see his hips and elbows are in the right place. And in the other location, we see that his shoulders come to forward, his hips up. And so we know that he's not activating his core. So it's pointless to do the plank. And it also detects other variations. People usually do the plank incorrectly. We similarly do the same for the squat. So you can see me squatting on the left and right. I'm doing it properly on the left. However, on the right, notice that I'm leaning too much on my left side. And so there's a misbalance there, and it picks that up. And it also takes into account my range of motion. So on the left too, since I'm doing my full range of motion, it's starting to count the repetitions. However, on the right, I do incomplete range of motion. So it tells me it's not counting my reps, and it's telling me I don't have the sufficient depth for it. So you can't cheat the system. And another exercise we track is the push-up. So our algorithm detects the misalignment of my neck. So this is a common problem people usually do for push-up and plank. It makes it easier for them, but it strains their neck. So it's not the optimal form you want to be in. So it tells me my neck is not aligned to my shoulders. So going forward, we'll continue to optimize and iterate the mathematical solutions, improve the current solutions with more advanced machine learning, and add more exercises to our library that expands beyond the exercises mentioned here. I want to give a special shout out to Hero House, SmartGateVC, EFSE Entrepreneurship Academy, and to our excellent team, Grisha, Ani, and Anush, for helping us on our mission to democratizing fitness. You can drop any questions you have in the chat below or email me. Thank you very much for listening.
Thank you for the presentation, Laura. Now please welcome For You AM team for their presentation.
Hi everyone. Today, Hovannes, Alex, and me will present what we have achieved so far in the AI Incubator program. I am Levon, the CEO of For You AM startup. For You AM is an online platform for gifts and flowers, which specializes in choosing the right gift for each recipient. Our mission is to be the most customer-obsessed company in the world. The problem statement is following: to provide customized gift options to For You AM customers, which will help them to choose the right gift for their beloved ones. What we will achieve? The solution will automate the gift selection process, which will increase customer satisfaction. Customers can easily choose gifts, which will increase the conversion rate of the website. We will show many products to different vendors in the recommendation system, which will give us a new partnership opportunities. The recommendation system will help us to scale fast. Hovannes.
Okay. So the first challenge that we have faced is the lack of data. The dataset that we were provided did not contain the valuable information regarding the receiver of the gift, which was of the highest priority when making the recommendation for us. The solution we came up with was to utilize models that do not require user-specific data. We also had model testing issues due to the fact that models are learning and collecting data on the fly, thus making it difficult to directly test the models. To overcome this issue, we collected the dataset similar to the on-the-fly generated data and tested the model performance on them. Finally, we had cybersecurity design issues as the model is highly dangerous in case a user gets public access to it. We solved this issue by placing the model in a separate environment, also encrypting the data passed through the model. Okay, we have developed 5 recommendation system models, out of which For You AM chose the 2 models that have the highest business value. The first model that was selected is the item similarity model, which is basically a natural language processing model that utilizes word over distance and Twitter's NLP corpus to make predictions. The second model is the gift advisor, which is a reinforcement learning model that is based on the contextual bandits paradigm. Okay, so first model that we created is the item similarity model. So imagine it as an all-knowing wizard hired by For You AM to recommend most similar products to the product of your choice. Every time you click on a certain item, the wizard receives the description of the item and uses his AI magic to recommend most similar items to you. So simply put, the model can be described as the Amazon's product similar to the current item section.
Our second model is the gift advisor. Imagine a smart robot sitting behind a website and playing a game with you. In our case, the goal of the robot is to recommend the best gift options to the user during the game. Your role as a customer is to provide hints to the robot, which will eventually lead to recommending the one gift that you have hoped to find. The first step in the process is when the user enters the gift advisor section of the website and we suggest them to play the game. As the second step, 4 questions pop up asking about the age and gender of the recipient, the relationship with them, and the occasion of the present. Next, we have created 5 age groups, gender groups, 3 relationship groups, and a couple of occasion groups of people. As an example of a group, imagine we have a recipient that belongs to the age group of 18 to 35 and is a female. The relationship between the person who buys the present and the recipient is professional, and the occasion of the gift is New Year. The model might recommend a scarf for this specific case. In the next step, customers will be given a list of products recommended by the model. When hovering on an item, the customer will be provided with more information regarding the item. The users have the option to rate and select the product. After all that, the selected items will be shown in the wish list. This was all for our presentation. Thank you all for listening, and if you have any questions, please drop them in the comments.
Thank you for UAM team for the presentation. Now, please welcome IMET Cloud team for their presentation.
Hi everyone, my name is Workya. I'm a plastic surgeon and co-founder of IMET Cloud. We are making photo and video editing app like a PixArt, but just only for plastic surgeons. The main task is creation of before and after illustrations. For example, if I have the slide, it's okay. For example, if I have photos and videos before operation, after operation, I need to put them together, make some alignments, replace or change the background, add logo, watermarks, sensor bars, change the body shapes, and many other things. The work is time-consuming and can take more than 30 minutes. Our service automates jobs using computer vision. Now imagine, just in 5 seconds, we can generate production-ready before and after video. The project is done by researcher Artyom, supervised by Chiner. Now Artyom will present some technical sides. Artyom?
Hi everyone. So in the framework of this project were conducted following steps. First of all was done face part detection for faces images. After it, noses were cropped from these detected images, and using classification algorithm, we understand type of these noses. After it, we tried to obtain algorithm for translation of image before operation of nose to after. In the end, as additional task, we also obtained background extraction using deep learning techniques. Let's see short demo video about conducted work. Here we trained UV4 detector and run it on test images. Inference for Full HD images were around 5 seconds, which is very good, and also output of model was pretty good. After it, we classified type of noses using convolutional neural network. Here showed images before and after operation of noses, and also inference of trained model on test images. In the end, we also obtained background extractor using deep learning techniques. Now let's put our attention on the result of each step. Here showed metrics of face part detector and its output. We can see that metrics are pretty good. After detection of face parts, we cropped noses, and using convolutional neural network, we classified them on test data set. Our model show 92% of accuracy. For obtaining image-to-image translation algorithm, we decided to train text-to-pixel, but it generated blurred results. One of the reasons in a similar result is concluded in the weak ability of pix-to-pix translated structured images. And another reason can be the lack of images for training dataset. However, research in this area should be continued. In the end, as additional part, we also obtained background extractor using U-square-net, deep learning techniques. You can see here that result was pretty good. And for future works, for improving image-to-image translation quality, we suggest trying following steps, especially trying self-supervised GAN for translation structured image, trying imaging painting, and just play with landmarks and try to find optimal combination for improving that result. Thanks for your attention. In case of question, you can drop them in chat or contact with me directly. Thank you.
Thank you for the presentation. Now, please meet Robodel Technologies for their presentation.
So, hi everyone, we are presenting Robodel, which is a high-tech solution to the last mile delivery. At Robodel, we are solving last mile delivery issues using robotics and AI. We build a self-driving delivery robot that delivers food to customers. After the robot reaches the destination, the customer just needs to unlock the cargo using the mobile app and take the food. What makes Robodel unique is that for food movement, we utilize not only sidewalks, but also bike lanes, which increases the robot speed and decreases the delivery time. Thus, one of the tasks that the robot has is the identification of drivable region for safe path planning. So we chose to solve the problem via semantic segmentation by leveraging artificial neural networks. The task of semantic segmentation is to assign labels to each pixel on the image. A good segmented image is shown on the right. As we can see, the road is colored as purple and the sidewalks are pink. We are focused on identifying 4 labels: crosswalks, sidewalks, roads, and bike lanes, as they are the important regions for the robot. We further relax our task to identify roads and sidewalks as a first step. So the environment is diverse. If we focus on the second image, the part that is adjacent to the sidewalk and separated by a line is considered to be a bike lane. From the image point of view, it has the same descriptive features as the road. For example, if we would crop only that part of the image and ask a person what is it, the most likely answer would have been a road. Also, for other labels, there is no single specification that one can come up with to define them. And because of this, it becomes hard for our model to identify the characteristics of certain labels. Also, our robot will carry 6 cameras and will observe 6 different viewpoints simultaneously, which means that whatever algorithm we come up with needs to process 6 images at once. On the other hand, the algorithm needs to be fast to ensure smoothness of the video and that we do not lose any information. It should support at least 30 frames per second on each camera. Given the device we have at our hand, we are restricted in terms of which kind of neural networks we can use, meaning we cannot use very big networks that consume a lot of resources and violate our speed constraint.
Here on the left side, we can see an input frame to the neural network. The picture in the middle shows the desirable output, and on the right, the result we have obtained. As we can see, the result is not perfect. However, we consider that mostly it achieved the goal of the task. In the form of large blobs, it is able to distinguish sidewalks from the road and mark the rest as irrelevant. We further optimized our network to run faster on mobile devices. We can see that on lower resolutions, we obtain almost 5 times speed up. However, there is a point in the image size that even optimization doesn't help, and we cannot spot improvements. We would like to share some interesting findings about the data that are preventing us from learning a better model. You can see that the roadside is colored black. If we look at the same part in the original picture, it has the same features as the sidewalk. However, for some reason, it was marked as irrelevant. The crosswalk that in our case we either have to choose as part of the road or the bike lane, in this case has features very close to the road. However, in the third image, it has features that are closer to the continuation of the sidewalk. This kind of discrepancies only confuse our model during the learning phase, as it needs to learn a lot of context. Thus, as first step towards improving the model will be more thorough moderation of the data. Improving network architecture along with making the task hard with additional labels. Also, we propose to use hybrid solutions for easily identifiable patterns as crosswalks. Thank you, and don't hesitate to reach us in case of any questions.
Thank you, Robodel team. As of now, we have had presentations from 6 teams, and we have 6 other amazing companies to go through. Please welcome Abed from 3Zug.
Hi, I'm Abel, the CTO and co-founder of Zug. Zug uses AI to convert portraits into illustrations, and we've already converted more than 400K portraits into illustrations for thousands of users. Before applying to the program, we had glam and anime styles for conversion, which didn't show much detail. You can see a few examples from our hand-drawn dataset on the right. Our main challenges throughout the program were creating more realistic, high-resolution art styles, developing real-time video conversion, and improving the model's diversity. Here, you can see an original photo of mine, the generated result before the program, and on the right is the more realistic version we have now. In order to get this result, we have tried many competitive techniques and none of them worked well individually. As a result, we did not only customize each algorithm, but combine them in one algorithm, which generates the more realistic hand-drawn result you see on the right. Our goal was not only to achieve realistic results, but also it is important for us to ensure good quality. The zoomed-in version shows that our new algorithm is able to generate high-resolution images, which meets our needs. After the successful result of the realistic portraits, we decided to generalize our algorithm from images to movies. The results were impressive. As you can see now, we have a real-time video conversion model for existing art styles. Once we had this result, we partnered up with Snapchat and integrated our models to Snap Lens Studio using their ML kit. By the way, these lenses work real-time on mobile devices. Additionally, it's in our DNA to be inclusive, so throughout the research, we try to extend our model to handle various ethnicities, age groups, and genders. In order to achieve this goal, we have started to assemble a more diverse dataset to use in our training process. We have promising initial results in this research direction, but the task itself is time-consuming. In terms of next steps, we plan on improving our diversity model, develop more styles with the new technique, and also publish a Snap Lens, which will be publicly available, and every one of you can try it. And right now, let me show a short demonstration of the work we achieved. So here is a live demo of the real-time video conversion, and you can see how good the model performs with various movements. Thank you. Let me know if you have any questions in the call chat or via email.
Thank you for the presentation. Again, a kind reminder, if you have any questions, you can use the chat or company emails for your questions. Next, please meet Amorous Medical for their presentation.
Hi everyone, I'm Ana Yeroyan. I represent Amorous Medical's image enhancement project as a researcher. The other members of our team are Supervisor Chinar Mostisyan and company representative David Nazarian. Firstly, a few words about the company itself. Amorous is a software as a service platform that accelerates clinical trials and guides precise interventions for sight-threatening disease with its AI/ML-enabled predictive algorithms. It also simulates the progression of the subject profiles that accelerates recruitment and requires fewer subjects. So passing to the problem statement, sometimes medical cameras, fundus, take poor quality photos of retina, the back of the eye. The low illumination level of the image often results in bad diagnosis. The old method to handle this problem is retaking the photos. However, for many clients, it is very inconvenient as it might take too much time. Hence, it is not a good solution. There also exists a math-based algorithm able to enhance the underexposed image and solve the illumination problem. Here's an example. The goal of this project is to find an AI-based algorithm solving the same problem better than the current existing one. In this slide, we can see the steps for data pre-processing. Firstly, we have a poor quality image, which we crop, apply on it our math algorithm to get the corresponding enhanced version. And then we combine those two images into one single pair, underexposed and exposed, which we will then feed to our AI models. Now let's explore the AI models. So after an in-depth research, we ended up with conditional generative adversarial networks, CGANs. The reason behind such decision is the already succeeded experiments done by these algorithms, especially pix-to-pix GAN. For instance, this day to night, from day to night, or from black-white to color translations, which are very similar to our problem. This is why we need to take this algorithm into the core of our project and make it appropriate for our data. In the next slide, we can see the results. So here in the left, we have our underexposed image, poor quality image. In the right side, we have the corresponding pair derived from math algorithm. And finally, we have, in the middle, we have the result of our AI algorithm, which is very similar to ground truth. We have also a short demonstration. So here we have our underexposed and its corresponding ground truth label exposed image. And our goal, as you can remember, is to generate from our AI algorithm. And we can see that our output is very similar to the ground truth. And here are some more examples. And we also take into account the time as a other way of evaluating the performance of our algorithm. Here I choose an interesting example. In the middle picture given by our AI algorithm, indicated by this red arrow, we have a blood vessel which is not present in this right image given by our math algorithm. Because blood vessels are the most informative part of those images in terms of making diagnosis, we can conclude that in this particular case, our model performed better than the math algorithm. However, there is a controversy case indicated in this blue circle where math algorithm gives us a blood vessel which is not present in our AI-generated image. Finally, let's compare our algorithms. We can see that AI-based algorithm works about 13 times better than its mathematical counterpart. And in terms of quality, we saw that our algorithm sometimes works worse than the math-based one. So the future work, by enlarging our data set or making our algorithm more flexible, we can improve it to perform better than math algorithm in any part of the image for any sample, or at least do not contain poor generated parts like this, where math algorithm performed definitely better. To sum up, we managed to make an AI doing image enhancement, which totally solves the illumination problem. So thanks for the attention. Feel free to email or drop your questions in the chat.
Thank you for the presentation, Aram. And now we will be moving to rumors monitoring. Please welcome Haik for their presentation.
Hi, everyone. My name is Haik, and let me introduce you to rumorsmonitoring.com. So here we go. Rumors Monitoring is an automated media monitoring platform. It's the first one in Armenia. It monitors media on a regular basis, collects all the web media in one place, analyzes articles and posts and reviews collected, offers solutions to over 40 companies and company groups in Armenia, and provides more services too. Now our goal is to monitor media, and by saying so, we mean analyzing the materials published on media. So obviously, in order to analyze them, we need to collect these data first, and we need to collect them from the internet. But collecting them by hand is a cumbersome task because a huge amount of materials is to be obtained every day from hundreds of different websites in different languages. So we need another approach. We'd like the computer, the program, to do all this data extraction for us. Our program will regularly get a list of articles, each given with its URL, and it will output its title, content, and date. That's the important part of the article given with this URL. And now the problem is, how can the machine find and extract them from an article, or more accurately from the URL of the article? Well, how do we humans recognize the title in an article? Obviously, thanks to our eyes, because regardless of the text comprising it of its language and so on, the title differs from other parts of the article with its appearance. Now, if a human can distinguish between the appearance of the title and not the title, we propose that the machine can do it too. And our solution uses state-of-the-art computer vision techniques to identify the title and the date and the content of the article. Here's how we do it step by step. First, our model takes the link to the article, then opens it in the browser and takes a screenshot of it. Here we can see the screenshot. Next, we give this image to our network, and we ask it to outline what it sees as the title, data, or content on the image. We get this output where you can see these rectangles here, which bound the article, the content, and the title. And in the next step, we extract them. We extract the text of these boxes. So we'll get this output from just from the URL. Now, to accomplish this task, we collected a data set of more than 30,000 fully labeled article screenshots from 150 unique sources, including international and local websites in 6 languages. Furthermore, due to this visualistic approach, our model is independent from the article language. That is, it works not only for these 6 languages as mentioned here, but for any other language written in any script as well. Now with this link put here, you can have fun by testing the model on a custom article written in any language of your choice real time. And here we can we'll observe how our model performed on an article written in Japanese. Here we can see it. So excuse me. And here we go. You can see the article. This is just an article I found on a random Japanese news website. We open our code, we run some prerequisites, and then put our link here. Our system takes this URL of the article as an input, and as we can see, it will now output the title, date, and content. So as we can assure here, our model is language agnostic, and it has no problem even with languages like Japanese. Languages it has never seen before, because we had no Japanese data in our no Japanese websites in our data. You have seen what was done so far, and there are some future plans as well. We think that these future plans will help to further refine the model. One of them is training our model on a larger data set after collecting more articles and more data. Another thing we can work on is to change the architecture of the network, that is to make the complex, make our model more complex, and it will achieve more, obviously. And then we can also make some, we can also take some steps to improve its speed. And I have to say that it's now, it takes only just 3 seconds or so to process a single article, but I think that we can halve this by doing some improvements in, for example, in the time it takes our model to load and inspect the article. And of course, as for the accuracy, we have also tried to combine some alternative methods too, and combine their output with the output of the current model to get a more accurate result. That's it. Thank you very much, and let me know if there are any questions in the chat. Thank you.
Thank you for the presentation, Haik. And now please welcome Mark from Freshmos.
Hi, everyone. Can you see my presentation? Sorry.
Yes.
Okay. Hi, everyone. I'm Mark, and with Sparta, we have prepared a report on a company called Freshmos. Freshmos is a mobile game development company, and we have worked on one of its games called Dogtown. By the way, Dogtown has reached over 7 million downloads in the last year. What we've done is, the goal of the project has been to identify the key driving factors of the advertisement revenue among the game users, and more importantly, extract any hidden insight or rules from the data that will eventually help the company to create a better ad strategy. We have got data for iOS and Android users, and for each user we have date when the ad is viewed, the country where the ad is viewed, and revenue per ad viewed. What we've done is, firstly, we have created more than 20 variables from the given data. We trained machine learning models on that data, and finally, we used explainable AI techniques to get insights from the model. Here, you can see some of the top factors driving the revenue according to our model. So the factors are mainly the same. However, the ranking of importance among iOS and Android users are a bit different. Now I will present a couple of insights that we've got from our model. Here you can see the PD plots, which show how the individual variable is driving the revenue change. So here the model tells us that the time passed after the last ad and the current ad should be around 1.8 hours for iOS users and 2.7 hours for Android users. For example, if an iOS user sees an ad, that means that the next ad that should be targeted to the that same user should be 1.8 hours later. The second insight is the daily ad counts, which shows that the model tells us that the more users see a user watches ad during the day, the less is the revenue per ad. We can see, however, that the revenue decrease has a diminishing effect, meaning that showing 16 or more ads per day doesn't significantly affect the revenue. And the last insight, which is quite interesting, is the hour of the day, which shows at what hours users should have been shown the ads. So the model tells us that the best time that we drive the revenues up to show the ads to iOS users is from 6 a.m. to 10 a.m. and for Android users from 7 a.m. to 12 a.m. Now, to sum up this insight, let me bring an example. Let's consider Ananya, who is an iOS user. He is a dedicated game user, and he's taking care of 3 different dogs in this game. So in order to get higher revenue per ad view from Ananya, we firstly should show an ad at 7 a.m., then show the next upcoming ad at 9 a.m., which will have around 1.8 hour interval. And last, show, in order to have high revenue per ad factor, we should not show more than 3 ads per day to Ananya. For the next steps, we are planning to do modeling on even a bigger data in order to get more accurate and robust models. We'll create even more variables, which will help us to have more insights and better explanations. And eventually, we'll create an algorithm that will customize it to our users. Thank you very much for your attention. If you have questions, drop them in the chat.
Thank you, Mark, for the presentation. Now, please welcome Expert Technologies team to present their research achievements.
Hello again. First of all, let me introduce you my team members. Researchers are Anna Hakhverdian and Miknarik Meherian. Supervisor is Mel Sagopian, and Expert Technologies company representative is Arek Gasparian. Today we are going to present you dialogue generation for Robin. This is Robin. Robin is a good-looking social robot that reshapes how we looked at children's care in hospitals. So what makes Robin so pleasant among children? He has very friendly design. Due to his facial expressions, he can easily build empathetic conversations with children, tell them funny stories, play with them interactive games, and also he can explain hospital procedures in simple ways. And at the end, Robin can report doctors about mental health of a child. Our task for Robin was design an algorithm that would generate dialogues. Add personality trait to it, as Robin needed to have consistent personality during all dialogues, and he had to remember all previous conversations with the child and also the content of the dialogue that he was engaged in. Our approach was research up-to-date algorithms for dialogue generation, then customize it according to our needs, and finally train on Robin's data. Anna?
Now I will dive deeper into our research and the results. First of all, we started with researching papers that answer our requirements when generating dialogue. During the research process, we found a newly made dataset, Persona Chat, that consists of dialogues between 2 people while having 5-sentence descriptions of everyone's personality. We found 2 papers that used this dataset to train their models, You Impress Me and Play-Doh. Both these models have 2 parts, a part that generates the next sentence given the memory of the previous ones, and a part that personalizes the generated sentence. The problem with these both approaches are the lack of pre-trained models and their code bases. So we tried another model, GPT-3, OpenAI Sprite. This model is widely known in NLP community. It is trained on many text data sets and for different tasks. And the best result we got was from this model. Let's see our result. Okay, here you see a child and Robin's conversation. The best part that illustrates the effectiveness of model is when the child says he likes chocolate fudge ice cream and asks Robin which flavor of ice cream it likes. Robin answers he likes chocolate flavor too. This means Robin understands and remembers the child's answers and makes an inference from it. Okay, so in the future, We would like Robin to have perceptual awareness, which means Robin must understand the dialogue topic and its environment. Robin must have short and long-term memory, as mentioned before, and also it needs to generate speech in a cute and Robin-like way. So, thanks for listening. If you have any questions, please ask them in the chat or mail us.
Thank you for the presentation, Expert Technologies team. And we have our final company, Forge Fiction. Let's hear their presentation.
Okay. Mm-hmm.
Hi everyone, I am Hübsime Sımbatyan. Under the supervision of Eric Arakelian, my teammate Anna Hafverdian and I were working on the project of book recommendation system for Forge Fiction in the scope of this program. After our presentation, you will see how artificial intelligence can turn our fantasies into reality. Couple of words about the company. Forge Fiction online platform that allows its users to rate with others and create a book by voting for the favorite one. Currently, has almost to work on books they are actually interested in. In other words, given the books, to merge content, which we approached by the following pipeline. We took books like vectors, then calculating the similarity score, we found the matching books.
Okay, I think most of the parts was lagging, so I will sum up a bit. So our problem was to find a book recommendation system using the books written in for fiction. And we approached this text this way. We first took like the first accepted chapters in Forge Fiction, and we took the 3,000 characters, which is approximately 700 to 900 words as our input data to our AI model. We use transformers, so widely known NLP architecture for our task. Vaguely to make sense of what it does, it takes the text that we give. It tries to understand how the sentences are connected with each other by paying attention to the parts that are mentioned in other parts of the text. In the end, it gives us a numerical representation, a vector of our whole text. We tried it on different architectures and found out that Albert gave us the best results. And then we used that word vectors to calculate cosine similarity between them. Simply put, it calculates the angle between two vectors, and the smaller the angle, the more similar the books are. So we can quite confidently say that our model reads and understands the text that we give, which I can show you right now. Okay, let's try first the Odyssey of NR. It's a book in Forge Fiction. Let's try it on our database. So it gives us sci-fi, mystery, fantasy, dark thriller, and it gives us confidence scores. Now, let's try the description of it. It is as I give a text to it, it is calculating the vector, so it takes a bit more long time. And also I'm doing on my local server, so you can see the book that it was described is in the first place. And let's try something else, like Batman Arkham City game description. Sorry, it takes a bit long time. And you can see Batman Huntress, Batman Gotham, comics, a superhero, the stuff that is related to Batman mentioned here. And okay, and in the future, we would like to try some other various AI architectures and attention mechanisms. And if we constantly get satisfactory results, we would like it to make it to production. Thank you for listening. If you have any questions, please put them in the chat and mail us.
Thank you for the presentation, and thank you for your patience with our technical issues. Now we will go through a few questions that our audience members have asked in the chat. First is MDH for Robodel. MDH loves Robodel and wonders if you have a point of view on different scenarios related to people appearing on streets. Things that would be the most relevant solution you could provide, and those are the hardest ethical questions to crack for automotive industry. Artakcan, I think you can answer the question.
Yeah, I'll take the question. Thank you for the question at first. So one thing at first that I want to mention that the Robodel, our robots will not drive on streets. So we are using sidewalks and bike lanes. So basically people that are on the street are not directly relevant to us, but on sidewalks, we always meet people. Also on bike lines, sometimes they can appear. So for this, what we do two things. The first thing, we try to identify those people using like object detection, basically. And we know that sometimes this is not perfect. So as a backup option, we are using some LiDARs. And with 100 Hertz frequency, we are getting data about the surrounding. Did I answer your question?
Okay, if you have any other questions,
yeah,
you can just write it in the chat section. We have another question for 3Zug from Sebuk Irakian. Can we find the Zug filters in Snapchat? I bet you can answer the question.
Thanks for the question. Right now, we don't have the Snapchat integration done fully, but we're planning like in the next 2 months to have ready Snapchat lens, which will be available like publicly.
Thank you for the answer. We have another question for you. Armen Vartanian thinks it's pretty awesome. And can you animate the background as well? Accuracy will be not as important, but it could make the overall experience pretty immersive.
Yes, we are planning to animate the background as well. And right now we are working on that. And as you are saying, the accuracy will be much so it will be like more not precise like the face converting part, but it will be
Okay, we have another question for 3Zug from Shalem Darmanjan. First, great tag and congrats on Snapchat. What was the frame rate Google Meet was buffering? Thank you.
It was running real time, like 30 FPS, and also it can run on mobile devices as well, and also like near real time, like 20 FPS.
Okay, thank you everyone for your questions. If there are no more questions to any of the... Oh, we have a question for the organizers. Why your house do not ever share this kind of video via recording? We actually do. You can check Hero House YouTube channel, and you can see almost all of our ever done recordings and different demo days, as well as different panel discussions. You're more than welcome to check that out. In terms of this recording, we'll be sharing this with registered participants and also in our Facebook event discussion. Thank you for all of your questions. If there are no more questions, I would like to thank once more the EFSE Entrepreneurship Academy for joining forces with us, SmartGateVC, for the second batch of the Hero House AI Incubator, and wish you all a great day. Thank you.